now? It is 4 o'clock.
Yes, ma'am.
Thank you. I'll share my PowerPoint presentation. Yeah, so here we go. Just 1 second. Right. So, when we talked about art integration in science, I had spoken about a whole lot of things which are common in art and in science. When we are doing art integration in mathematics, what do you think is the purpose of art integration in mathematics other than just creating interest? So, can you say that what is the purpose of art integration in mathematics? Yes, can you write in the chat? What do you think is the purpose of art integration in mathematics? What is your understanding? Other than creating interest, what else could be the purpose of art integration in mathematics? I cannot see anything in chat. Well, if you ask me, I would say that maths is a very abstract thing. It can become very abstract unless it is explained very well and visualization is done very well. But when we integrate maths with art, there is a lot of tangible thing to it. There is a lot of in-hand things which convert the abstract ideas of mathematics into something that children can feel, they can see, they can hear. So that makes it more realistic. Otherwise, children feel that maths is all in mind only, right? So that is the idea of art integration in mathematics. And going further, now let me take up topic by topic some ideas in mathematics. So when you start with class 6, you have the first topic is knowing our numbers. And the chapter deals with big numbers and some conversions. So now if you look at the big numbers, first art that you can make them do is large number art. Now you see there are huge amount of numbers ranging from 0 to 9 using which this portrait has been made. So similarly, you can make the children maybe do their own picture, their own portrait using numbers, and of course, they might require a graph paper or maybe some software, but they can find out how it can be done. So this is the first art which is very much possible, which deals with large numbers. Then this is another art. Now you see, these are only dots. On the first view, you feel that it is an eye and you feel that it is in a plane. But when you see the side view, these are all the balls, solid balls, which have been hung from the roof with very tiny threads, and you can see the threads over here at the top, right? So you can have a two-dimensional picture converted into a three-dimensional assembly of a large number of balls which are of different sizes and which are arranged in different planes, in different vertical planes to give an impression of a two-dimensional picture which looks very realistic. So that is another way large numbers can be brought into art. And this is creating a perceptual shift actually from from 3 dimension to 2 dimension, because actually your arrangement is 3 dimensional but it looks 2 dimensional. So this is an art by Michael Murphy. Then next is mirror removal by Tyler Hobbs. Now you see, this is made up, this art is made on the mirror, not really mirror, but a partially shining glass plate. And you can see there is large number of lines, and the lines are all curved. So this kind of effect, mirror-like effect, can be created on a glass sheet by making these large number of lines. Then another topic that this chapter takes up is conversion. So this is a painting, or this is a depiction of conversion from imperial system to a metric system. And you can see that this is the inch foot system, shows the imperial system, and this is the metric system showing lines in centimeter. And why this huge sphere has been shown, can you write in the chat box? This tall man is of course representing the colors of the flags of British Empire. But why do you think that this sphere is shown here with the metric scale? So what is your idea why the artist is depicting the centimeter scale in hands of a sphere? Let's see what is your idea in the chat box. Why do you think that this sphere is there? I'm just waiting to see your answers. Don't wish me good afternoon, good evening anymore. Kindly write the answer. I do wish you a very good evening. So kindly write in the chat box, what is artist's purpose to measure any concrete objects? No, that is the purpose of the scale. But what is the purpose of this sphere? Why the sphere has been shown, and in the hands of the sphere, they are putting the centimeter or metric scale. Well, the idea is that the whole earth, or all the countries on the earth, have adopted the metric system by the SI system convention. So that is what this is. The artist has tried to depict that from the British system we have come to the metric system, and the whole of the globe, all the countries in the world had adopted this. Then you can make this cootie catcher, which is again showing conversions of metric units. Here you are showing a second into nano or microsecond. I hope you all know what is this cootie catcher. You can कई हम लोग छोटे थे तो इसको दिन रात बोला करते थे इस तरह से four raised pieces come into your four fingers, and when you open and close them in different pairs, you get different things to see. So this is called a cootie catcher in English, and you can, when the children play with it, they can easily remember the conversions of liter into milliliter, liter into centiliter, or here decimeter, decameter, and then kilogram, and so on and so forth. So that is another art idea for children to learn conversions. Now the chapter also talks about estimation. So here is one example of artistic estimation. You see, the children are embroidering these patterns, and they have not put any marks as to how they will place these patterns at equal distances. So, and these also are to be put at equal distances. So what idea is being shown, that you can maybe put pennies at equal distance, and then by perception you can divide, or you can place these motifs at equal distance. So that is an idea about estimation, which can be used in embroidery. And then when we go forward, now the next topic that I take up is basic geometrical ideas. So you see here the straight lines. Now this embroidery is totally through straight lines. Even the curves have been made up of small straight lines. So then look at these this artwork. This is a huge artwork which has 17 acute unequal angles. And of course, the angles are all made by straight lines, but all these are different angles. We may not ask the children to make such a huge depiction, but we can ask them to make it on a small scale and put it as a decoration piece in the classroom. Then This is another artwork by Vasily Kandinsky. He's using different shapes in mathematics to make a modern art. It doesn't really mean anything in specific, but it shows that how the whole world is made up of lines, which may be straight or which may be curved. Now, this is a beautiful sketch by, again, Vasily Kandinsky, who is showing angles. Now, look at the beautiful way in which angles have been presented. So, this is 30 degree, 60 degree, 90 degree, 120, and so on. But look at the way the colors are being varied and such a beautiful presentation. So simple and elegant, but beautiful. Now, this is Carol Richardson, who is using only right angles. And she has named this artwork as right angle only. So you see, all the triangles are right angle triangles. There is at least one right angle in all the triangles that have been used here. Now, this is the art of bisecting angles. Now, normally in geometry, we are doing it by protractor or by compass. But this art of paper folding, origami, they have beautiful techniques of bisecting the angles. And this is one such artwork by Brett Jordan, where by bisecting the angles, this beautiful bird has been made. So you can give this idea and make children wonder that without the instruments also, how you can bisect the angles and then put it in such a beautiful shape. And yes, I can read your comments that when you were young, you used to do this. And it's good to remember our childhood in the classroom, because that is what connects us to children and that is what keeps us young and our excitement also alive. Great. Now, this new angles to art. So, see how these bricks, which are having actually right angles, how they have been arranged to create this structure where you can see so many other angles by shadows, or in the whole structure, pyramidal structure, how angles have been created. Then look at these artistic ways of representing angles. I especially love this sculpture with the chairs. So the chairs don't have right angles here, but they have some acute angles. And by making one on the top of the other, such a beautiful architecture has been, sculpture has been presented. और ये वाला जो पेंटिंग है, इसमें देखिए कर्व लाइन से जो एंगल्स बनाए हैं वो कितने आर्टिस्टिकली, इतनी सिंपल तरीके से इसको प्रेजेंट किया गया है. अब ह्यूमरस एंगल्स, अब देखिए क्या सिर्फ लाइंस और एंगल्स से कितना ह्यूमरस चीज बनाई गई है. ये एक कैट है, फिर ये यहाँ पर जो हमारे लिप्स और नोज के एंगल्स हैं उनको डिफरेंट एंगल्स से प्रेजेंट किया गया है. और फिर ये कॉम्प्लीमेंट्री एंगल्स का कार्टून है. यू आर अ क्यूटी. सो अ क्यूटी इज actually another way of saying acute. So this angle is telling the pink shape, you are a cutie. Okay. Then look at this angle art. अब यहाँ भी acute angles, obtuse angles, different angles को कितना beautifully colors के through present किया है. तो बच्चों की imagination, बच्चों का color sense, बच्चों का hand coordination, बच्चों का विजुअलाइजेशन, ये सारी चीजें हम इसके थ्रू कितना ब्यूटीफुली रिप्रेजेंट कर सकते हैं. फिर है अंडरस्टैंडिंग एलिमेंट्री शेप्स. अब ये फ्रैंक स्टेला की वर्ल्ड फेमस का आर्ट है, जिसमें उन्होंने सर्कल, सेमी सर्कल्स को कितने ब्यूटीफुल स्ट्रिप्स के थ्रू ये चीज बनाई है. फिर सेम फ्रैंक स्टेला की ये एक और प्रेजेंटेशन है जिसमें कलर्ड स्ट्रिप्स को उसने कितना अलग ढंग से प्रस्तुत किया है. तो इस तरह से हम बच्चों को कह सकते हैं कि वो इन शेप्स अपने माइंड के विजुअलाइजेशंस को किस तरह अलग अलग शेप्स के थ्रू प्रेजेंट कर सकते हैं. अब ये मोज़ेक फ्लोर पैनल है जो कि सेकंड सेंचुरी एडी का है, रोमन पैनल है। इसमें आप देख सकते हैं कि छोटे छोटे एकदम स्क्वायर पीसेस को जोड़ जोड़ के कितनी तरह के क्वाड्रिलेटरल्स बनाए गए हैं, स्क्वायर्स हैं, पैरेललोग्राम्स हैं। सो एंड द कलर कॉम्बिनेशन इज मेकिंग इट लुक सो ब्यूटीफुल। इवन द ये जो बीच की पोर्ट्रेट है रोमन एम्पायर की, वो भी कितना ब्यूटीफुली इन छोटे छोटे स्टोन्स को जोड़ जोड़ के बनाई गई है। अब ये बीडेड क्राउन है योरूबा पीपल्स, नाइजीरिया वालों का, जिसमें कि उन्होंने ये जिगजैग और ये क्वाड्रिलेटरल्स जो हैं इनको जोड़ के देखिए कितना ब्यूटीफुल ये एक स्ट्रक्चर बनाया है। फिर मंडला तो आप सब जानते ही हैं, आपने भी अपने बच्चों को बताया ही होगा कि कैसे मंडला बनाते हैं, और इसमें भी डिफरेंट ज्योमेट्रिकल शेप्स बनाई गई हैं जो कि आप भी आई एम श्योर बनवाते होंगे। अब ये क्वाड्रिलेटरल्स यूज करके जो वन पॉइंट पर्सपेक्टिव होता है आर्ट में, उसको डिपिक्ट किया गया है कि किसी भी पेंटिंग में अगर दूर की कोई चीज बनानी होती है तो वो एक पॉइंट लेते हैं अपने माइंड में आर्टिस्ट, और फिर वहां से सारी लाइंस इमेजिन करते हैं कि वो उनकी तरफ आ रही हैं, और फिर वो ऑब्जेक्ट्स को डिपिक्ट करते हैं। तो ये क्वाड्रिलेटरल्स को यूज करके उन्होंने जो वन पॉइंट पर्सपेक्टिव है उसको दिखाया गया है। नेक्स्ट इज अगेन क्वाड्रिलेटरल्स। अब वॉन्की क्वाड्रिलेटरल्स देखिए, ये पेपर फोल्डिंग से बनाया गया है और ये पूरा का पूरा खुल के एक वन सिंगल पीस बन जाता है। एक प्लेन में एक प्लेन शीट बन जाती है, लेकिन जब इसको फोल्ड करते हैं तो ये इतनी इंटरेस्टिंग शेप बन जाती है। तो इस तरह की चीजें बहुत बच्चों को इंटरेस्ट करती हैं, और यू कैन शो देम इन एग्जीबिशंस ऑल्सो। अब ये पॉलीगन एम्ब्रॉयडरी है बाय जेसिका स्टैली कैरोल, और इसमें तरह तरह की अगेन स्ट्रेट लाइन से ये सारी शेप्स बनाई गई हैं थ्रू एम्ब्रॉयडरी। अब इंटीजर्स की बात अगर हम करें तो मुझे चैट बॉक्स में बताएं कि हाउ इंटीजर्स आर डिफरेंट फ्रॉम द नंबर्स दैट वी हैव टॉक्ड अबाउट टिल नाउ। आप चैट बॉक्स में बताएं कि इंटीजर्स की क्या स्पेशलिटी है। जो मैथ्स के लोग हैं या जो मैथ्स के लोग नहीं हैं, what do you understand by integers? How integers are different from other numbers? When we talk about integers, how they are different from whole numbers? Collection of positive and negative numbers. Yes, collection of positive and negative numbers. So now you see how artistically the idea has been represented. ये तो सिर्फ इंटीजर लिख दिया है एक बड़े आर्टिस्टिक तरीके से, और उसमें आप देखिए कि यहाँ पर नेगेटिव और पॉजिटिव नंबर्स दोनों ही लिए गए हैं। अब यहाँ पर देखिए इंटीजर आइडियाज इन ड्राइंग। तो कैसे इंटीजर आइडियाज लिए गए हैं कि यहाँ पर लैंड है और फिर यहाँ ऊपर स्काई है और इसके नीचे डीप सी है। तो ये क्या दिखा रहा है कि जो लैंड का लेवल 0 है और उसके ऊपर जो चीजें हैं वो पॉजिटिव नंबर से रिप्रेजेंट की जाएंगी, और जो उसके नीचे चीजें हैं वो नेगेटिव नंबर से रिप्रेजेंट की जाएंगी, एंड देयरफॉर इट इज गिविंग इंटीजर आइडियाज इन ड्राइंग। देन फोटोग्राफ का कोलैज है। अब फोटोग्राफ के कोलैज में भी यही आइडिया है कि ये लैंड है 0 लेवल पे, ये टॉप ऑफ द माउंटेन जो है ये 200 इसको पॉजिटिव 200 मीटर्स बताई गई है हाइट, इसको -10 और ये और नीचे -12। सो अगेन थ्रू फोटोग्राफ collage the integers are being depicted. Going forward, this is another lovely piece. This is by artist Ricky van Berkom. Now the temperature change has been depicted. So this line depicts some average temperature, and whenever the temperature goes up above this base temperature, then the positive numbers are shown in red above this line, and then temperature goes below that, the embroidery is with blue black color in different shades below this baseline, and the different shades represent different temperatures. So according to a color code, the embroidery has been done, and again integers in terms of positive changes in temperature and negative changes in temperature. That idea of integer has been depicted through embroidery here. Are the slides not changing? Please write in the chat box. Do you see the slides changing or not? Yes, slides are changing. So maybe for somebody it is frozen, but otherwise the slides are changing. Okay. Now this is again temperature quilts. So here also the numbers are, some numbers are positive. Maybe yellow color is taken as the average, and all temperatures higher than that are going in shades of red, purple, and all temperatures below that are going in shades of blue and so on and so forth. So this is the integer graph that I was showing, the idea that is being shown, that 0 is depicted by this color and all temperatures above 0 are shown by these different colors. All temperatures below 0 are shown by these colors, and accordingly this daily chart of temperature has been made in this particular shape. Then we go to fractions. We are not blind. Sir, you are not blind, but for other people it is changing. So maybe your computer has got frozen, that is why. So now this is about depiction of fractions. So keep, change and flip. When you're dividing two fractions, one fraction by the other. So what do? First fraction you keep as it is. Then the division sign you change to multiplication sign, and the second fraction you flip. So that is what they are showing through this artwork. Then ratio and proportion can be beautifully shown through multiple artistic forms. One is the story that I would like to tell you. So this is a story about ratio and proportion having a fight. So there were two good friends, ratio and proportion, living opposite to each other. Ratio used to live in a building which had two floors, top floor numerator and bottom floor denominator. While proportion used to live in a house having two side-by-side portions on left side, antecedent, and the right side one consequent. One day they had a fight. Ratio said that I am larger as I have two floors, and proportion said I am better as I have two portions side by side. Arguments kept on going until a wise man, Equation, came and told them that they both are equal and same. It's just the way you see. He asked Ratio to see proportion house by tilting neck by 90 degree. And then he noticed that proportion also has two floors, and then proportion sees ratio house by tilting the neck 90 degree, and found his proportion were also side by side. They hugged each other and stayed together in equal ratio and proportion after that. So this is the story. Then look at this painting depicting Gulliver Travels. Now using this, you can discuss a lot about ratio or proportion. You see whether the men are small or big like the Gulliver. The proportion of their body parts is still the same. In fact, you can show this and you can have a survey in the classroom that there can be tall children and there can be small children. You ask them to calculate the proportions of, let's say, their head, their face to their arms, or their arms and their legs, or their torso and their legs, and then let everybody find out the ratios and check whether even though their heights and the lengths of each individual parts are different, but the ratios may be similar. So that is the idea of using such artwork. Now, simple equation. So look at the ideas of simple equation on clothes. Look at the shirt here and the t-shirt here. It says there is they are showing this mantis, and then it's some kind of elvish. I can't read it. So a person who doesn't understand maths is saying it's some kind of elvish. I can't read it. So it's a fun thing written on the t-shirt. Then you can give the idea of balance in the equations by showing some hanging things which are balanced. So here you see these are different branches with which there are some leaves, and they are hung in such a fashion that the whole thing is hanging horizontally. So from each side, the left side, the right side, the front side, and the back side, all are balanced. And that is the balance which we also require in equations in mathematics. Then this is mathematical art with equations. Now there are softwares online where you just put the equation and the software will convert into an artistic form. And that is what we are trying to do with mathematics. Then triangles and its properties. So this is another example of art with triangles. You see here, all the shapes are utilizing triangle. Then congruence of triangles. And now you see this is congruence art. There you can give this to children and ask them to identify the triangles which are congruent. Here it's very simple. In the middle one, it's very easy to see. And in others also, in the right one also, it is easy to see. Left one, they may take some time. But yes, you can give such artistic challenges in the classroom. Then look at this drawing by R.K. Mandal, in which again he is using so many congruent triangles, and children can have fun recognizing this. Rational numbers. Now, rational numbers. What do rational numbers mean? Can somebody write in the chat box? What do you understand by rational numbers? Yes? Can maths teachers or other people who understand rational numbers, can you write in the chat box what is the meaning of rational numbers? Or please write in the chat what is your understanding of rational numbers. P by Q form, in the form of P by Q, where Q not equal to 0, of the form P by Q. Okay, Q is not equal to 0. Okay, so how do you think this zebra, this depicts rational numbers? Now, I'm not going to tell you. You have to tell me, how do you think that this zebra depicts the idea of rational numbers? Yes. So how do you think P by Q is being represented, P by Q form is being represented over here? Right. Okay. So in the form of P by Q, where Q is not, that is okay. But how do you think, can you see a zebra in this artwork? How do you think that zebra is being depicted? Can you see these curved lines which give the impression of something being raised? So there are some lines which are curved, which give the sense illusion of being raised. And then there are some lines which are not raised. So can you understand how this is giving an idea of rational numbers? Then here also, you have some portions which are raised, which are lighter, and then there are some portions which are dark and they are supposed to be lower. And so this gives an idea of the form of P by Q, where P are the things which are raised and Q are the ones which are below that. Now, I leave it to you to interpret how they are depicting the integers. I don't see many of you contributing in the chat. I will be happy if you can contribute your ideas in the chat box instead of writing the poetry. Now, exponent and powers. So for exponent and powers, I would like to show you this video.
is on the shoulder of the big, big bass. It is big bass number. Yeah, I'm an exponent, so potent, I can make it grow. Don't you know I'm exponential? I've got the power. You've got potential.
So they are going to show the powers of being in different ways.
And I said multiply the base by the base as many times as I am. Multiply that base. I said multiply the base by the base. See all it can be with the power of me.
So what do you think they depicted in this scene? Whose power do you think was depicted just here in this particular scene? Can you tell me whose power was being shown here in this particular scene? Third power of 4. You see 4 into 4 into 4. This is 64. So they are just trying. Another way.
Yeah, I'm the little number that breaks down walls and makes you multiply yourself like paper dolls. Yeah, I'm an exponent, so potent, I can make it grow. Don't you know I'm exponential? I've got the power. You've got potential. And I said multiply the base by the base as many times as I am. Multiply that base. I said multiply the base by the base. See all it can be.
So what I am trying to tell you is that children can be imaginative with the way they represent the powers and exponents. Now this is an English song, but बहुत अच्छा होगा अगर आप अपने अपने जगह की लैंग्वेजेस में इस तरह के बच्चों से सॉन्ग्स लिखवाएंगे और उनको बोलेंगे कि वो अलग अलग तरीके से रिप्रेजेंट करें एक्सपोनेंट्स एंड पावर्स को. जरूरी नहीं है कि यही आइडियाज लिए जाएं. हमारे बच्चों में बहुत ही अच्छी इमेजिनेशन है और बहुत तरह तरह से वो उसको रिप्रेजेंट कर सकते हैं. आगे बढ़ते हैं. अब सिमिट्री की बात करते हैं हम कुछ. सिमिट्री में देखिए नेचर में सिमिट्री बच्चे आपको बता सकते हैं कि अब यहाँ पर डॉग्स की सिमिट्री आप देख रहे हैं कि डॉग्स के फेसेस में कितनी सिमिट्री है. अब क्या आप किसी एक और ऐसे जानवर का नाम लिख सकते हैं चैट बॉक्स में जिसके फेस में भी बहुत सिमिट्री पाई जाती है? और किस जानवर के फेस में बहुत सिमिट्री? बुल, ओके, और जीब्रा और कैट, आउल. इनफैक्ट ज्यादातर के फेस में सिमिट्री पाई जाती है. आपके हमारे फेस में भी पाई जाती होगी. तो it is just a fun question. You know that almost all living beings, all animals, insects are quite symmetrical. Even देखिए जैसे पीकॉक कितना ब्यूटीफुल है अगर सिमेट्रिक है. आपकी बटरफ्लाई है ये सिमेट्रिक है. अब लीव्स देखिए ये भी कितनी सिमेट्रिक हैं, कितनी ब्यूटीफुल लग रही हैं. अब ये वेजिटेबल्स में सिमेट्री देखिए कि अगर हम एक मटर की फली को खोल के देखते हैं तो देखिए उसमें भी सिमेट्री है. एक भिंडी का क्रॉस सेक्शन लेते हैं तो उसमें भी सिमेट्री है. तो अब ये फ्रैक्टल सिमेट्री है एक तरह की. जो ब्रोकोली है, रोमानेस्को ब्रोकोली है ये, इसमें भी एक फ्रैक्टल सिमेट्री है. यस, लीव्स में आप ठीक ही कह रहे हैं, उसमें भी है. फिर स्नोफ्लेक्स जो होते हैं उनमें भी सिमेट्री है. तो हम इस तरह से बच्चों को तरह तरह के एग्जाम्पल्स देने को कह सकते हैं विच हैव एंड हाउ दे कैन बी कन्वर्टेड इनटू आर्टिस्टिक फॉर्म. अब ये देखिए ये एक आर्टिस्ट हैं जिसने लायंस के फेसेस को इस तरह से उनके फेस की जो सिमेट्री है उसको किस ब्यूटीफुल तरीके से डिपिक्ट किया हुआ है. फिर दिस आर्टिस्ट इज एंड्रियास प्रेस. अब ये पाउला माइया. अब ये डॉग्स को के फेस में जो सिमेट्री है उसको इसने स्केलिन ट्रायंगल्स और क्वाड्रिलेटरल से रिप्रेजेंट किया हुआ है. तो देखिए हर ट्रायंगल आपको स्केलिन नजर आ रहे हैं और क्वाड्रिलेटरल्स नजर आ रहे हैं. ब्यूटीफुल कलर स्कीम्स एंड रिप्रेजेंटेड द डॉग्स. फिर आप किस तरह के क्रिएशंस बनवा सकते हैं क्लासरूम में. जो भी पत्तियां, फूल, पत्थर, डंडियां, ये सारी चीजें अवेलेबल हों लोकल एरियाज में, उनसे हम इस तरह से सिमेट्रिक डिजाइन्स बनवा सकते हैं बच्चों से। उसके बाद फिर ये देखिए सिमेट्रिक पेंटिंग्स एंड ड्राइंग्स बनाई गई हैं। ये जोकर कितना मजेदार लग रहा है, सिमेट्रिक, बोथ साइड से सिमेट्रिक है। और इसमें इस ड्राइंग में एक तो रिफ्लेक्शन भी नजर आ रहा है, वो भी इसको सिमेट्रिक बना रहा है। और कलर स्कीम्स आर सो ब्यूटीफुल। अब ये बीडेड मास्क है, ये मास्क चेहरे पे पहना हुआ है इस लड़की ने, और इसमें भी देखिए सिमेट्री है। तो जरूरी नहीं है कि हम फूल पत्तियों से ही, जानवरों की पेंटिंग से ही सिमेट्री का आइडिया आगे लेकर जाएं आर्ट फॉर्म में। इस तरह के मास्क भी बनवा सकते हैं। और ये इस तरह के पेंडेंट, हार जो लड़कियां गले में पहनती हैं, इसमें भी सिमेट्रिक बनाया हुआ है। तो इस तरह से बहुत तरह के डिजाइन बना सकते हैं। आइडिया ये है कि हम बच्चों से जो भी बनवाएं उसमें एक क्वालिटी हो, हम उनसे ये एक्सपेक्टेशन रखें कि वो एक्सेलेंस ऑफ वर्क हो उनका, वो खुद करें, लेकिन उसमें कितनी सफाई से उन्होंने बनाया है, कैसी कलर कॉम्बिनेशन लिए हैं जो कि बहुत अट्रैक्टिव हैं, देखने में बड़े अच्छे लगते हैं। वो आइडिया है कि मैथ्स तो होना ही चाहिए, मैथ्स का जो ऑब्जेक्टिव है हमारा वो तो पूरा होना ही चाहिए, लेकिन साथ साथ जो आर्ट फॉर्म का ऑब्जेक्टिव है वो भी पूरा होना चाहिए। अब देखिए यहाँ पर एक और ब्यूटीफुल चीज, आप इसको देखिए, ये देखिए बीड इन्फिनिटम, ग्वेन फिशर ने 2016 में बनाया था। लेकिन ये बीड को किस तरह से धागे में पिरो के बनाया गया है, इसको भी कितना आर्टिस्टिकली रिप्रेजेंट किया है। तो इतना माइन्यूट स्टैंडर्ड ऑफ एक्सीलेंस मेंटेन करना, ये बहुत बढ़िया, बहुत बड़ी चीज होती है जो हमको बच्चों को जरूर सिखानी चाहिए। ऐसा नहीं है कि जैसा तैसा उन्होंने कलर कॉम्बिनेशन बना के रख दिया हो, काम में बारीकी और खूबसूरती दोनों चीजें बहुत होनी चाहिए। आगे बढ़े, अब देखिए ये फोटोग्राफी है, कितना ब्यूटीफुली इस सिमेट्री को उन्होंने रिफ्लेक्शन से दिखाया है। एकदम सिंपल चीज है, कांटे को मोड़ के, जो खाने वाला कांटा होता है उसको मोड़ के उसमें कीवी फ्रूट को काट के रख दिया मिरर के ऊपर, और उसको फोटोग्राफ किया है। कितनी ब्यूटीफुल कलर स्कीम है, सिंपलिसिटी है, बट इट इज सो ग्रेसफुल, सो एलिगेंट। अब मैं आपको एक अमेजिंग डांस दिखाती हूँ जो कि एक सिमिट्री के बेस पे किया गया है, और ये बड़ी वर्ल्ड फेमस बैलेरिना है दियाना विश्नेवा। ये आप इनका डांस देखिए। धीरे धीरे आपको क्लियर होगा, ध्यान से देखिए आप, बहुत ही खूबसूरत ये डांस है। ये मिरर, मिरर के ऊपर कर रही है ये डांस लेट कर।
Precious love can only come from He's born a kiss of dignity. My precious love will only come
Okay, so we will move on from here. I just wanted to show you a glimpse of the ideas that people have in the world. And everything is about ideas. Going forward, this is another dance, thousand hands. This is Bodhisattva that they are showing. This is Chinese art group of disabled people. See the amazing symmetry. So you can watch more of this on the internet. I just wanted to show you the ideas that you can bring in the classroom. Word. Now we can also have a lot of classroom displays which convert mathematics into a real art form. And look at this. This is a Pythagoras wall. So how this is one square, this is another square, and when you add the square of these two, you get a third square, which is shown here. But the beauty is that it starts from this central set of three squares, and then with each square, they are going on to connect other two squares whose sum will give you this. Again, this goes on to connect these two squares whose addition will give you this. This goes on to connect with these two whose addition gives you this. So like this, from a very big set of three squares, it is spreading into smaller and smaller squares. And this is really a fabulous wall that I have loved. Then look at this. Look at this wall. Today I am feeling positive. Today I am feeling improper. Today I am feeling irrational. Today I am feeling alternate. Today I am feeling platonic. So in platonic, they are showing platonic solids. Today I am feeling disconnected. So here you have two disconnected shapes. Then today I am feeling complex. So you have some complex numbers being shown, and so on and so forth. Today I'm feeling normal, and there they are showing one perpendicular line. I'll just show you one of them, this one on the next slide. See, today I'm feeling positive. Now, what a beautiful depiction of positiveness. Here, this is the number line, and then from here to here, you are going on to greater and greater positive numbers, and this is the frog who is jumping from one positive number to another positive number because he's elated, he's feeling positive. So this is how you can make a wall display like this one using the idea of different kinds of numbers. Today I am feeling unreal. So you see here you have iota equal to under root minus 1. Balanced, I'm feeling balanced. So they're showing a balance equation in the two pans of balance, right? So this is the beautiful wall display. Then look at this, how to learn maths. So learn a new skill, practice the skill, make mistakes. Do you understand why? If yes, go to fix the mistakes, test the skill, and then you mastered. If you don't understand why, then no, go ask for help, then fix the mistake, test the skill. If again you make the mistake, then go back to this loop. So this is another very beautiful way to, make children grapple with the problems that they face in mathematics. That maths is nothing but about practice and finding your mistake and trying to understand your mistake and then correcting them. So a beautiful display on the board. And then look at this idea, the faces behind the formulae. Now, faces behind the formulae, there are so many formulae in mathematics, and they have researched. I'll show you one of them, like this. So, what is this logarithm? Y equal to a raised to power x equal to log y to the base a equal to x, which were an important aid to calculation, also popularized the use of decimal point. Now, who did it? Florence Nightingale. When? During 1820 to 1910. And what did she do? She pioneered the visual presentation of statistical data. So something like this. This is the whole wall, which is showing different mathematicians and what they did, when they did. What is one fascinating fact about them? So look at the beautiful way the wall has been decorated with mathematical ideas. Then squares and cubes. Now look at the roof. The squares are 1, 4, 9, 16, 25, 36, 49. Cubes are 1, 8, 27, 64, 125. So again, it's a beautiful way of decorating the classroom walls. Then vowelless. Now this is another amazing idea. See, the key words in mathematics have been taken and put here by removing the vowel. And then this is given as a quiz to the children. How? This is the direction. These maths keywords are the maths keywords are missing through vowels, missing their vowels. Sorry, these maths keywords are missing their vowels. Can you work that? What they are? Prizes for the first 3 fully correct answers. So I'm also guessing here. So can you guess what is this number? Write in the chat box. What is this word? What does this word represent? Where I'm moving my cursor. Yeah, proportional, wonderful. What about the next one? What about the next one? What do you intersect? Okay. What is this one? The green one. What is the green one? Congruent. Great. And what is this? What is this? Yes. What is this? I don't know. And what is this blue one? What is this blue one? This is vertex. Okay, great. This is, of course, triangle. So like this, you can make a board and have a quiz in your classroom so that, children recognize the mathematical terms that they're using in the classroom. Then you have mistake codes and word wall. So why are they there? Because, children get sometimes very disheartened with maths. So just to boost up their morals, these are some of the quotes. Mistakes are the portals of discovery. Anyone who has never made a mistake has never tried anything new. This is by Albert Einstein. Then Henry Ford said, if you think you can do a thing or think you can't do a thing, you are right. Means if you think you can do, you will be able to do. And if you think you can't do a thing, you will not be able to do it. You can do whatever you think you can. If you think you can do it, you will do it. If you think you can't do it, you will not be able to do it. So such quotes will boost children's morale. And then this is again another word wall where the words with vowels, of course, have been written over here. So together it looks so beautiful on the wall. And then you have these geometrical posters. Well, these are by Disney Art Deco series, and they've been prepared by David G. Ferraro. So these are all the different princesses whose stories they are telling. So one is the Sleeping Beauty here, the other is the Frozen Princess. But you see, they are all made with geometrical shapes. So children can also make such posters in your classroom. So that is the maths integration from me today. And these are my coordinates, my Facebook and LinkedIn page. If you would visit them, you will be able to see the very different kinds of programs that I do. And if you would like to connect with me, this is my mobile number, which is a WhatsApp number, and you can send your message there. If there are any special topics on which you would like me to take up any training, you can please write on this mobile number. So thank you so much. And I'm very happy that I was able to do this webinar today with you. If you have any questions, please do let me know.
Thank you, ma'am. Good evening.
Thank you. If there are any questions, I will take them up. Otherwise, I'll call it a day. Yeah, for Hindi also I can do if you would like, or if your complex tells me to do, I will certainly do for Hindi also. Okay, then if there are no questions, I'll be leaving the session. Thank you, ma'am.